All right, let's talk about one of the most fundamental things you'll ever do in AWS, managing your data. We're going to dive deep into the core operations for EBS volumes and snapshots, how to manage them, move them around, and most importantly, how to protect them. Let's get right into it.
Hey everyone, I'm Srinath Kaithoju. I'm going to be walking you through some of the most common and critical challenges you'll face when you're managing data in the cloud.
So think about this for a second. Your application's data might be safe right now, but what happens when you need it to grow or move? What if an entire region goes down? These aren't just abstract ideas, right? These are the real-world problems that keep us up at night. The disk is almost full, the dev team needs a perfect copy of production yesterday, or the worst happens, a major outage. Well, today, we're going to walk through how to solve all three of these.
Okay, so Section 1, your first data volume. Before we can do anything cool, we need to set the scene. We're not starting with some crazy complex setup. Nope, we're starting with the basics. Just a single server that needs its own dedicated disk for data.
So here's what we're working with. Our whole setup is sitting in the London region US 2. We've got our server, we'll call it EC2A, and it's in a specific availability zone, US 2A. And attached to that server, we've got a simple 10 gig GP3 EBS volume. We've already mounted it to the /data directory. Super simple, totally standard. This is our starting point.
All right, Section 2, growing without downtime. And here it is, the first problem. It's that alert that nobody wants to see. Disk full. Your app is choking, it's about to fall over because it has nowhere to write data. Let's fix this, right now. And the best part, we're going to do it without taking anything offline.
So, how do we do it? It's actually a really elegant three-step dance. First step is in the AWS console. You literally just find your volume, click Modify, and bump the size from 10 gigs up to 20. And AWS immediately starts provisioning that extra space in the background. Then you SSH into the server itself. You run two quick commands. First is grow part. That tells the server's brain, the partition table, hey, there's more disk here now. And then you run resize to a fest to tell the file system, okay, go ahead and actually use all that new space. And that's it.
And the most important number in this whole operation? What's the impact on your application? How much data did you lose? How many seconds of downtime did you have? 0. A big fat 0. Your application just keeps on chugging along, totally oblivious to the fact that you just saved it from a major headache. Okay, moving on. Section 3, cloning data between servers. So here's the next common request, right? The dev team comes to you and says, we need a perfect copy of the production database for our staging environment. We can't test on the live data. How do you get that data from server A over to server B without any fuss?
The hero of this story is the EBS snapshot. And what is that exactly? The best way to think about it is like a perfect photograph of your disk at one exact moment in time. It's a point-in-time copy, it captures everything, but it's not the disk itself. It's more like a blueprint stored separately and super efficiently by AWS. Now this slide, this is probably the most important concept we're going to cover today. It's the fundamental difference between a volume and a snapshot. An EBS volume, your actual disk, is stuck in a single availability zone. It's physically there, it can't move. But a snapshot is a regional resource. It lives at the region level, completely independent of any AZ. And that difference is the key. It's what gives us all this power and flexibility to move data around. If you get this one concept, you've unlocked data mobility in AWS.
So the workflow to clone the data is super logical once you understand that. Step 1, we take a snapshot of EC2A's data volume. Step 2, we use that snapshot, which, remember, is a regional thing, to create a brand new volume. We can place that new volume in the same AZ as our second server, EC2Me. Then it's just a matter of attaching that new volume to EC2B, mounting it, and bam, the exact same data just appears, ready for the dev team to use.
And I really want to hammer this point home because it trips a lot of people up.
A single EBS volume can only be attached to one EC2 instance at a time. You can't just unplug it from one and plug it into another simultaneously. Now, there are special volume types for that, but for 99% of use cases, this is the rule. So the proper, safe, and scalable way to share data between servers isn't to try and attach the same disk. It's to use the snapshot and create new volume method. It really is the standard AWS pattern.
Okay, let's take everything we've learned and apply it to the ultimate test. Section 4, surviving a regional disaster. We're not talking about a single server failing anymore.
We're talking about the entire London region going dark. It's a total catastrophe. But because we've been smart and we have our snapshots, we actually have a way out.
So, step 1 in our disaster recovery playbook is this. Copy the snapshot to a completely different region. Remember how we said snapshots are regional? Well, AWS lets you copy them between regions. So we just initiate a copy of our latest snapshot from London over to our DR site, let's say in Frankfurt.
Okay, step 2. Create a volume from that copied snapshot. As soon as that copy is finished, and it's usually pretty quick, that snapshot now exists as a native object in Frankfurt. It has zero dependency on London anymore. So we can just treat it like any other snapshot and use it to create a brand new EBS volume in any of the availability zones over in the Frankfurt region.
And the final piece of the puzzle, step 3, is attaching it to a recovery instance. We spin up a fresh server, we'll call it EC2C, over there in Frankfurt. We attach our newly created volume, mount it up, and just like that, our application's data is alive and well in a completely different part of the world, totally unaffected by the disaster in London. That is what we mean by resilience. All right, section 5, the production-ready checklist. So we've walked through how to grow a volume, clone it, and even recover from a disaster. That's awesome. But doing this once in a lab is one thing. Doing it for real in a production environment is a whole other ballgame. There are a few more things we absolutely have to consider to make this process solid and secure.
So here's that checklist. This is what turns a proof of concept into a real production strategy. First, tags. You have to tag everything, not just for tracking costs and ownership, but for driving automation. Next, encryption. Your data should be encrypted at rest using KMS. This is non-negotiable. And when you copy snapshots across regions, you have to think about the KMS key permissions too. Then there's cost. Snapshots aren't free, so you need a lifecycle policy, probably using something like Data Lifecycle Manager, or DLM, to automatically create and delete them so your build doesn't explode. Of course, you need to lock down permissions. Who is actually allowed to create, copy, and restore from these snapshots? And last but not least, cleanup. What's your plan for tearing all this down? You have to have one to avoid leaving behind orphaned, expensive resources.
So let's recap. We've taken our simple data volume on quite a journey. We made it grow, we cloned it for another team, and we even saved it from a regional apocalypse. Your data is now safe and it's mobile. But that brings up the next big question, doesn't it? Is it automated? Because clicking around in the console is great for learning, but the real power comes when you turn these workflows into a hands-off, repeatable, automated process. And that's where tools like Data Lifecycle Manager really shine. Thanks for joining me.